Today we'll be making an interactive wave simulator, and you might be wondering what the heck this red line is behind me. Well, as you can see, I take my mouse here and I drag it and I can actually create waves like this. Now this is coded entirely using the wave equation, the full wave equation, using damping and stress strain coupling. It's a fourth order differential equation, and you can simulate it using time steps, and you can take user input and sort of have that define certain boundary conditions on the wave. So here I'm dragging the wave and you can see that sort of it's reacting to my input and simulating the physics. So my goal is that this application that you see here, the wave, will be one application in many. Eventually we'll have a pendulum simulator, we'll simulate hockey pucks bashing into each other, bouncing off walls. We'll have a whole bunch of physics simulations that we code together in JavaScript. So if you enjoy this video, if you like doing this and you want to create more and you want to create your own library of physics simulations, be sure to like and subscribe. So the two files that we're going to need when creating this simulation is index.html. That's an HTML file that you can open in a browser like Google Chrome. And then you need a JavaScript file. The JavaScript file is going to be in charge of running the simulation, doing the animations and plotting, whereas the HTML is basically going to be just for display. So what I have here in my HTML file is I draw a canvas. That's just something you display in the browser so you can interact with it. The way that you interact with it is through the JavaScript file that I have here. So this is a JavaScript script, as you can see. And what it'll do is it can actually interact with this canvas, run a simulation, do a plot, animation, whatever, and we'll get the simulation of the wave that we want. So now that this is done, I'll just save this. There's nothing in index.javascript right now. It's empty. And what I have here is I have something known as Live Server installed. If you look down here, you can see the Go Live button. Click to run Live Server. You can install that as an extension in VS Code just by typing Live Server. I already have it installed, but you should install that as well. And you get a little button down here, and if you click Go Live, what it will do is it will run this index.html file that you have. But of course, right now it's blank. It doesn't do anything. So if I go to index.js, if I console.log, something, hi, his, and I save that and I reload this page and I open up the developer tools, you can see that his is logged. So the live server is really nice because if I make a change here and save it and I reload this, it will automatically just be updated like that. So it's a very easy way of making little edits and seeing things show up in real time. So as you can see in the HTML file, I've called the canvas CW. So it has a certain ID. That means I can access it in JavaScript. So if I go to my index.js, I've added a few things. I've created a canvas variable in JavaScript. So I've accessed that CW from HTML. So now I can interact with it. I'm going to make the context as the 2D context of the canvas. So it's just a 2D plot that we'll be dealing with. And I'm going to initialize a few things. I'm going to create my mouse X and Y coordinates. I'll just initialize them as 0. We'll edit that later. The other thing I want to do is I want to pick up the string when I animate and drag it around. And so I need a variable that determines whether or not I'm dragging the string or whether or not it's just, going on its own. And so I'll create that as false. There's a few modes here that I was playing around with, and I'm going to, just to start, I'm going to make it so that whenever you drag, only the left end of the string goes up and down. And finally, there's the mode here. So there's two different modes I want. I want it so that sometimes when I drag, only the left side of the string goes up and down. So I could drag anywhere, but the left side follows, or I could drag and it's that position of the string that goes up and down. So I'll leave it as move left end for now. So this is the initialization. So what I've added here are event listeners. These are things in JavaScript that whenever you do an action in the browser, it will change some of the variables that you have. So for example, here's when I move the mouse, when I click the mouse down, or when I hold the mouse up. And so basically this is sort of setting up the simulation, little tools that I'll need. So whenever I move my mouse, I want the mouse X and Y coordinates to be wherever the coordinates are of the mouse on screen. So what this event listener does is it triggers on an event E. This is a JavaScript function, and it will grab the client X and client Y, which are just attributes of the mouse coordinate. So I can move the mouse around and it will track. Whenever I click the mouse down, that means I'm dragging. So this variable is dragging will go to true. And when the mouse goes back up, is dragging will turn to false. And finally, there's an event listener here. So whenever I resize the window, I also want the canvas to resize. So if I, for example, am moving this like this, and the canvas gets resized, I want it to automatically resize. And so that will basically just say the canvas.height. The new canvas height is going to be the inner height of the entire canvas, and the width is going to be the inner width of the entire canvas. So what I'll show now is that if I console.log every time I move this mouse, I'll delete this in a sec, but this is just for testing. So mouse X, and I save this and I rerun this. Every time I move the mouse, it's going to log down here the X position. So over here, obviously I'm closer to 0. And if I move right, the numbers get larger and larger and larger. So this is just a way of, like, whenever this event happens, whenever the mouse is moved, this number gets put down. So that's what we need. That'll be useful because when I'm grabbing my string at a certain position, I need to know what the X coordinate is so I can move the string up, of course. And so this is going to be a useful feature. Now, the next thing I want to do is I want to create a class that actually represents the string object. And you might think, well, that's very simple. You have X coordinates and Y coordinates, but I think encapsulating it in a class makes it a little bit easier to handle everything that's going on. And the reason for that is that when you solve the differential equation, you need points before the current time in order to update the time step. And you'll see that in a second. But anyways, the string here has a constructor. So whenever I call to make a new string, I feed in a variable capital N. And N is going to be the number of points on the string, right? It's a discrete method of modeling a string. There's not infinitely many points. There's N points. So maybe like 100 or 200. I'll save that in an attribute called N. The next thing I'm going to do is I'm going to create an array like this. Now, this looks very weird. And in Python, this is really simple. But if I show you exactly what this does, if I create an array X on the outside here, and I'm going to make, say, 100 points, and I'm going to go I over 100. All this does is it creates an array from 0 to 1. I'm taking 100 points, and I'm mapping each point to the point number. So this goes from 0 to 100 divided by 100. So when it's at 100, it's equal to 1. When I is equal to 0, it's equal to 0. So this is just a linear array. And of course, I can console.log this, and I've removed the other console.log. So if I redo this, you can see that this is just an array of linearly spaced values. That's how I create X. And then the Y array, so the initial Y coordinates of the string are going to be 0. So all I'm going to do is I'm going to take each value in X, the same length, and I'll just map it to 0. So I just have an array of 100 zeros. So I have my X coordinates and my Y coordinates. These are some parameters of the string that I'll discuss in a second, gamma and L. And then dx is just the spacing between the points, and dt is the spacing between time points. So let's actually look at what those variables mean. So the true wave equation with damping and with stress-strain coupling, by the way, this is still an approximation. Like, you can go higher and higher and higher order derivative terms. This is just one of the approximations. It looks like this. So if y is the height of the string and x is the sort of horizontal position, the differential equation looks like this. So d squared y dx squared minus 1 over c squared, c is the wave speed, minus gamma dy dt, this is a damping term, minus L squared, fourth derivative, this is a stress strain term. So it makes it so that the string is almost a little bit rigid as well, equals 0. So that's the differential equation. We have boundary conditions, for example, that it's fixed at both ends. In the case of this simulation, I'll move the left side of the string. So this will actually be dependent on the user input with initial condition. And my initial condition is just that it's 0 everywhere. And so, yeah, I've talked about the parameters. So I can turn this equation here, which is a continuous equation, into a discrete equation. So there's the discrete approximation for a derivative, right? You just know rise over run. You take those points on the function and you get that. But of course, second derivatives and fourth order derivatives also have approximations. So my second derivative can be written like this, and I'll specify what these variables mean. Basically, m here, so the superscript, that's not raised to the power of m. This is the mth time point, right? So time always goes in the upper index. So at time m, right? And j is the spatial index in x. So j goes from 0 on the left end to j equals 100 on the right end. And so this derivative in space, of course, time is always the same because you're just taking the derivative at a given point in time. So m is constant and j changes. So this is my second order derivative here in space. My second order derivative in time, well, now j is constant, right? I'm just dealing with a specific point, and m is the thing that changes. My linear time derivative like this, And my fourth order spatial derivative can be approximated like this. This should actually be a 6 in the middle. Good thing I caught that. So this is my fourth order spatial derivative. And then what I can do is I say, well, I want to simulate the string moving, right? I want to get future time points based on the previous time points. That's what a simulation is. We look at what the string has done before and what it's going to do in the future based on what it's done before. That's a differential equation like this. And so what I can do is I can solve for yjm plus 1. This is like the next time, right? So if I know what my string looks like at time m minus 1, and I know what my string looks like at time m, I can solve for ym plus 1. This is just a linear equation. If I, write this equation and solve for the yjm plus 1, I get the following equation here, right? And yjm plus 1, so the coordinate j, so I can do this equation for all different values of j. So j equals 0, I can solve this equation. J equals 1, I can solve this equation. I just plug those in. For the m plus first time in the simulation is equal to this. So this is my factor here. So if I know what the string looks like at time 0, and I know what the string looks like at time 1, so 2 little frames of the string, I can calculate the next frame. And then I can use those 2 frames to get the next frame and keep going and going and going. And that's exactly why I have my first y array like this. It's just all zeros. And the y at my first time step is also going to be all zeros. So the first time is 0, the next time is 0, the string isn't moving, there's no velocity. And yt2, it's also all zeros, but this is what I'm going to update in the move function. So we'll get to that. The first thing I want to do though is define the update function, right? So I want to just write this equation as, in JavaScript so that I can call it in the move function. So what I have here is this function here. It takes in the ith coordinate, so that's the spatial coordinate on the string. It takes in the string at time, this would be like m minus 1. This is the string at time m, so the first 2. It takes in the wave speed, it takes in gamma, which is the damping constant, L, the stress strain, delta x and delta t, so the difference in position between the points and the time difference. And what it will do is it will return yt2, so the next time step at coordinate I. So you need to run this for all the different coordinates on the string to update the string. So what we want to do now is actually draw the string on this canvas that I have here. Right now it's empty, right? And so think about what's actually going on here. We have a string with horizontal position between 0 and 1. That's how I define the array. And y is just all zeros right now. And so I want a way to actually draw this string on the canvas. But the canvas works in terms of pixels, right? There's so many pixels horizontally and so many pixels vertically. What I want to do is I want to convert that string so that it stretches all the way across here and plot it. So what I need to do for that is I want to convert my string coordinates, which go between 0 and 1 and x, and whatever numbers in y, and actually plot them on this canvas here. So this might be between 0 and 300, for example. So what I'm going to do is I'm going to write a function that takes the string coordinates, which I define as follows. String goes between 0 and 1 in xs and ys. So these are my string coordinates. I want to convert them to the canvas coordinates xc and yc, which are going to be the coordinates in this window. Because the string coordinate goes between 0 and 1, if I just multiply by the width of the canvas, this will go between 0 and the width of the canvas. So the string going between 0 and 1 will go between 0 and the whole width here. And I can do the same sort of scaling for y. I'll scale by the canvas width as well. And I want the string to be in the middle, right? So y equals 0 is up here. That's how it works in HTML. And I want it to sort of come down to the middle. So what I'll do is I'll add the height of the canvas divided by 2. So now my string y position, y equals 0, will correspond to this sort of line here. So I basically transfer those equations to this function here. It takes in the string coordinates, which are 0 and 1. And it just basically returns these equations here. And because I have a transform like that, there's also an inverse transformation. If I know my coordinates on the canvas, I should be able to get my string coordinates. That's what this function does. It's basically just the inverse of these equations here, solving for xs and ys. And so I have a function that also does that. So with those functions defined, I can now define a function that will actually draw the string on the canvas. So what it will do is it will take in the string s, which is an instance of this class here, which of course has all these attributes, and it will take in the ith frame, right? So that's the ith sort of location. What it'll do is it'll take the I minus first point and the ith point, and it will draw a little line segment between them, and it will sort of do that for all lines on the string. So we've defined context above as the canvas, the two-dimensional, sort of platter on the canvas. So this is a variable we have here. In order to do this, we begin a path, we define the line width and the color, right? So then we actually get the coordinates of the string. And I'm basically using the string to canvas coordinates. I take the I minus first point in X and the I minus first point in Y, plug it into this function, and I get my first point that I draw between. By the way, if you haven't seen this notation before, this is a way to easily define variables in JavaScript. Because this returns X canvas and Y canvas in this object like this, I'm just extracting this variable as whatever X canvas is returned as, and this variable as whatever Y canvas is returned as. I do the same thing for the ith point here. I'm going to remove this logging thing here. And basically what it does, in order to draw between the 2 points, I move to this position and I draw a line to this position. So that's these coordinates that I get here. So it'll draw a line between those two for that particular I value. If I loop through all the values of the string, it will draw the full string. Then I stroke, and that will actually draw the line. So then I can create a new string of 200 points, and I'll call move once. Move will draw the entire string, and I can save this and reload this page, and you see that I have a string drawn here. So right now the string is kind of steady. It's not really doing anything. Eventually we want to create an animation with it using the move function of the string class. And so you can see right now, obviously the move function isn't actually moving the string. It's just going to draw the string using this function. And so what we'll do is we'll create the animation function framework so that it works. And we'll actually make a nice looking canvas here. So the first thing you do is you define a function called animation. You call this JavaScript function request animation frame on the animation. This just fills the whole thing with the color black, the whole window. And I'll call s.move, and basically what happens is every animation frame, which is 60 frames per second, it's going to call the move function over and over and over again. So here I've defined my new string. I'm going to set the size. You can see that it's not actually equal to the canvas width yet because the size hasn't been set using this event listener right here. And then I'll call the animation function, and all it's going to do is it's going to redraw the string over and over again. Of course, nothing is going to change because I haven't added the dynamics of the string in the class yet. So if I save this and reload this here, you can see that my string goes from the 0, the left side of the canvas, to the right side of the canvas. It's drawing over and over again, but nothing is actually happening to it. So let's actually update the move function so the string has the dynamics of the wave that we want. So we'll implement two things. We'll implement the boundary conditions, and we'll implement the partial differential equation, where I loop through each sort of segment of the string using the coordinates around it, and the times before and the times after I update the point. That's what a differential equation is. So the whole point of the move function is we're going to update this array here, yt2, using the previous 2 time points, because we need 2 time points before, like I said, to get the current time point. So we'll actually use 2 points for the boundary conditions, not just the leftmost and the rightmost, but the 2 points to the left and the 2 points to the right. The reason we do that is because we have a 4th order derivative. And so we need to access points, 1 to the left and 2 to the left for each point when we update the PDE. What I mean by that is that yj, the next point, depends on yj minus 2. So there's going to be 2 points to the left. So the only points that we can update are the 3rd point, onward, and then not the last 2 points. So our boundary conditions are going to actually have to fix the first 2 points because we have this 4th order derivative. So my array that I'm updating, I set that equal to whatever the previous value of yt1 was. That's equal to 0. So this is going to equal 0 for the boundary condition. Same thing for this. The reason why I don't just set it equal to 0 is because sometimes I'm going to be dragging the left side up and down. So my boundary is going to be, depending on what I'm doing with the mouse. This will basically set it so that the new value of yt2 is going to move to where the mouse is, and the mouse will update this.yt1. And I do the same thing on the right-hand side. So then what I do is I update my PDE step. This is where I actually go and I solve this equation, or I just use this equation to update my differential equation using the function that I defined above here. So basically what it does, and by the way, I've changed the loop so it no longer goes from 0 to the full length. It's going from 2, so the sort of second point, to the second last point. It's not using the first 2 points. And like I said, because this has to access a point 2 steps before, If I put it plugged in 0 there, it couldn't access negative elements. So I go from 2 to the final point. And again, that's required because I have a fourth order derivative. And now once I draw the string, I need to change because now I'm moving to the next time point, right? So I've updated yt2. And then what I do is I'm going to say that this.yt0 now becomes yt1, and yt1 now becomes the current yt2. So my current frame yt1 is the new yt2. So I'm moving to the next step. I'm updating the arrays by copying the old ones, then I can get the following step. And so it will draw the specific frame. Remember, drawString accesses yt2. So this current yt2, things get updated and it will draw the next yt2. So of course the string is steady, it's not moving at all. If we want to create some dynamics to the string, maybe we should move one of the points of the string up and we'll see a wave actually propagate across. So in order to do that, let me just, I'll remove this after, but I'll set the 50th point of this to 0.5, let's say. And if I run this, the wave should propagate throughout the string. So if I load this animation, you can see the 50th point, it was raised up and then it sends these high frequency waves throughout the string. The waves sort of propagate. There's of course damping that's occurring. The wave starts to settle. Remember the coefficients I set here, gamma is 200, L is 0.002. The wave speed is 1/100. And you can see that the wave starts to sort of settle over time. Because I raised one particular point up very high, of course you get all those high frequency waves. So now what I want to do is I want to create a function that when I click down on the mouse and move the mouse up and down, I want the left side of the string to also move up and down. And so thankfully I have these functions here. I have mouse move that tracks the position of my mouse. You saw that earlier in the video. And you saw these function here that it sets this variable isDragging is true when the mouse is held down and isDragging is false when it's not held down. And so basically if I click down and move the mouse around, I want this side of the string to move up and down. That's if I'm moving the left end of the string. That's one of the options of this simulation. So what I'm going to do is I'm going to get the y string coordinate based on the mouse x and mouse y coordinates. And thankfully I have that function, which I defined sort of here, right? It's the inverse of this. I can get my string coordinates from the canvas coordinates. This is in sort of pixel integers, and this will give me values between 0 and 1, sort of the string coordinates. And so if the mode is move left end, which of course I've defined up here just to start. So what it will do is it will take the first 2 points here. Remember, those 2 points aren't updated in the update function because of that fourth order derivative. But it will take those first 2 points and it will update it to be the y coordinate string here, which of course is from the mouse. So then in my animation function, I can add this line of code here. So if isDragging is true, so if the mouse is sort of held down, drag the string. So I can save this, and now when I run this code here, if I pull like this, I can actually see the waves being made by the string. Of course, they're decaying because there's a sort of damping constant to the string, and I can add more and more, and you can see that the strings as the waves interfere with each other, and then they pop out the other side just like waves should do. So the simulation is looking good. So the unfortunate thing right now is that the animation's a little slow. I kind of want the waves to move a little bit faster. But you have to be careful with updating this parameter c, because if c gets too high, it turns out that you reach a stability condition if this factor, so c dt over dx squared, is too high. So if c gets too fast, it will break the animation and you'll get these crazy divergence that goes on. For example, if I set c is equal to 1/20, I'm pretty sure this will break the animation. You can see that it breaks because things are diverging. So there's a maximum limit to c. So the question is, how do we make the waves faster? One way to do that is in each animation frame, you move the string, so you update it 5 times, you don't draw it, and then on the 5th time you update the picture. In order to do that, I'm going to put a draw parameter here in the move function, and I'm only going to move the string or draw the string if move is true, right? Then what I can do is I go down to this function here, and I'll change these 2 lines with this. And so what this will do is it will loop down from I equals 5 to 0. And I'll move the string every time, but I'm only going to draw it if I equals 0. And of course, every time, also if it's dragging, I'm going to drag the string as well. So this will speed up the waves by a factor of 5 because I'm dragging it, or I'm updating it 5 times, but I'm only drawing it once. And I have a little error here. This should be draw, not move. So I save this and I'll reload it. And now you can see that if I update the waves, they're moving 5 times the speed. So now my animation is looking pretty good. I'm pretty happy with this. And you can see the waves move, you can see them decay, and you can also see them interfere with each other. So in my drag string function here, I'm also going to add another mode, which is drag center. So in this case, rather than moving the left side up and down when I drag the mouse like this, I want it to drag the coordinate that I'm actually clicking at. So that's another sort of mode for this simulation. In order to do that, rather than updating the 0th point, I'm going to update a point where now xstring is being used, by the way. So it gets the coordinates of my mouse, it converts it to string coordinates, which is between 0 and 1 here, and it's going to take s.n times xstring. And you might think, well, what the heck is that? Well, remember, say there are 100 points in the array, and the array goes between 0 and 1, right? So maybe I'm clicking at 0.7 here. Well, then if there's 100 points, then 0.7 is the 70th point of that array. So s.n, which is 100 times 0.7, gives me 70 here, right? And so it's going to access the 70th element of that array by rounding, because maybe there's a decimal error if my mouse isn't exactly on an integer. It will access that element of the array, and it will update it with yString being the string coordinate corresponding to where my mouse is. So let me change the mode here. I'll comment this out, and I'll change it to drag center. So by center, I mean where the mouse is centered. And I go like this, and now wherever I drag on the string, it drags like this. And as you can see, there's a lot of very interesting dynamics here. I can sort of send a wave like this, and you get high frequency. If I click, then I get a sort of instantaneous thing here. Of course, as it decays, it's nice. It sort of comes to a steady constant. I can go like this. What's really interesting is you can try to get standing waves going. So if I move this up and down like this, if I vibrate it at just the right frequency, you can almost start to get a standing wave like that. So this is sort of like the third harmonic. So it's a great way to play with this sort of thing that's going on here. So this is sort of the basic introduction to this simulation. I have it working, it's doing fine, but I'm going to add features to this in future videos. I want to sort of play around. I want to create something that automatically maybe moves this up and down. I want to create other features that you can define your own function, for example, on a little widget and vibrate this at a certain frequency and try to get the standing waves, other things like that. So this app is going to be updated in the future. If you like this video, please remember to like and subscribe. Join the Discord server as well. Check out the merchandise, the beautiful shirt that I'm wearing here, and I'll see you next time.